Hello everyone, good afternoon. Hopefully you all are doing well on this Tuesday. Feels like Wednesday, but we're getting there. Slowly but surely we are getting there. Does anyone have any questions before we get started? Like I said, we're not going to wait significantly long anymore. If people are late, they're late. We're just going to go right into it because I don't want to waste too much time. Good afternoon, Matten. Good to have you join us. Anyone else? Anyone else? We got 6 people watching so far, so that's pretty good. Anyone else? Okay, so quick announcements before we get started. Hi, Julia. So the big thing is that your 2 math space assignments have, or is it 3? 3 math space assignments. I recorded the marks onto Google Classroom, onto Teach Assist. So your marks are updated, but they probably didn't change your marks by a significant margin. I only took marks that actually increased your mark, but most of the increases were like 0.1, 0.2%, so it was not too significant. But if you needed that 0.1, 0.2%, you got it. So there's that. Second, we are done chapter 6, well 6 and 7 kind of together, which is logarithms and exponentials with the quest. So if you have not finished that, please finish that and hand that in, and I will be marking those end of this week or early next week. So we're going to be moving into chapter 8 today. So let's look at chapter 8, which is starting to look into combinations of functions, or combining functions. Okay, so let's take a look at this. Most of these lessons will be fairly short now, or at least I think it'll be fairly short. There will be some longer ones, I think, later this week as we dive deeper into compound functions, but the first few lessons will be pretty short, so today should be done pretty quickly. Okay, so adding and subtracting functions, right? So adding is obviously called a sum. So the sum of functions can be written in 2 different ways, where we can say h of x is equal to f of x plus g of x, or the function h is the function f added with the function g, right? Now the other way you can write that, instead of writing h of x, is f plus g of x. And so that's just saying the function is f plus g added together, which is written in terms of x, and that's f plus g, right? And of course, difference can also be written in that form. F minus g is equal to f of x minus g of x. So the notation is exactly the same. As you've seen before, it's just these 2 are kind of the special ways of writing it now. And you're going to see more different types of ways of writing, like f plus g, f minus g, as well as multiplying and dividing, that we'll get into tomorrow. So when you want to graph the sum or difference of functions, pick an x value and determine y values for each function, then add or subtract the y values. Okay? So once again, reading that again, when you want to graph the sum or difference of functions, pick an x value and determine y values for each function, then add or subtract the y values. So essentially, it's just saying pick x, plug it into the function, and add or subtract the result, which is exactly what you're doing within these equations, right? So that's pretty straightforward. Algebraically, it's just combine the 2 functions, simplifying where possible. Essentially, we're doing a lot of algebra here, basic algebra. So this first lesson should be pretty straightforward. The only thing that you've got to be aware about is actually how domains change and how ranges change. That's the only, I guess, hard part of the lesson. So here, functions can only be combined for x values which are valid for both functions. So if 2 functions exist, they can only be combined for specific x values as long as x values both exist in each function. So this is where the domains of the functions overlap, which is called the intersection of the domains. Okay, so the domain of f plus g is equal to the domain of f intersecting with the domain of g, right? So this is intersection or intersecting, right? So a lot of times when we write mathematical statements, you can read it out in English. It's a full sentence, right? So saying this again, the domain of the function f plus g is equal to the domain of the function f intersecting with the domain of the function g. Okay? So this is nothing new to you. All this is a fancy way of writing the domain of the new function where you add or subtract the functions can only exist where the original functions overlap, right? That's it. So when we look at this example, let's go through some basic examples of functions here. So we're given function f and function g, and it's asking us determine the domain of each function, determine the domain of f plus g, and then determine what f plus g is. Okay? So we're looking at these situations here. So first part, A, domain of each function. So domain of f is equal to, well, what are the x values of f? Well, we have 1, we have 2, and we have 3. Pretty simple, right? The x values of the f function is 1, 2, and 3. So that must be the domain. For the function g, the domain of g, that must be equivalent to, well, 2, 3, and 4. So 2, 3, 4. And there we have it. So pretty straightforward there. Now it asks us determine the domain of f plus g. So the domain of f plus g, like we said, is equal to the domain of f intersecting with the domain of g. Okay? So it has to intersect with domain of f and domain of g, which means when we look at the domain of both functions here, we're looking what numbers repeat, what numbers exist for both domains. And so that would be 2 and 3. 4 does not exist in the function f, and 1 does not exist in the function g. So as a result, 2 and 3 are the only intersecting domains. And so as a result, the domain is literally just 2 and 3. And that's it. So now when it asks us what is f plus g, so what points make up f plus g, right? So the function f plus g is equal to, we have our x value, and then our y value is adding since we're adding the two functions, we're going to add the y values of the two functions. So we're going to go -5 plus -2. Sorry, you can't see that. -5 plus -2, right? And that's going to give me -7. And I'll write that out in a second. And then the second one, we're taking the x value of 3 in the domain, and that's going to give me 7 plus 3, which is 10. So just to kind of show you here, this is -5 plus -2, while this is 7 plus 3. And we get that from the original y functions, right? We just find the y value of the original functions and we add them together if they're the same x value. And that's it. That's example 1. So this is how the domain changes in the new function, and this is how the ranges will change in the new function. So let's kind of go into a little bit more detail. What if we're not working with just points, right? We as grade 12 students are working with functions, and not just point functions. We're looking at like y equals x squared, y equals x, y equals root x, y equals 1 over x, right? We have the variable x written inside it to make sure that the domain covers all real numbers, right? We want to work, what if the domain is all real numbers? What if the range is all real numbers? What changes then? So on the second page here, we have another example. We have example 2 here. It says let h of x be equal to f of x plus g of x, and it says determine the equation for the function h of x when f of x is equal to x squared and g of x is equal to x. And then we're going to sketch each function on the same grid. Okay, so simple enough. Let's first figure out h of x, which is equal to f of x plus g of x. And well, what was f of x? F of x was x squared. And g of x is x. And so we can just break those brackets, which just gives me x squared plus x. Wow. Not difficult, right? We're literally just adding those two functions. You know what the functions are. We're just putting them together. Pretty straightforward stuff. Okay? So nothing is particularly changing here. But if we were to graph it, well, I mean, graphing these functions isn't particularly difficult either. So let's kind of separate it into three sections. Let's do x, f of x, g of x, and then h of x. Okay? So when we want to graph all of these, it's going to be the same stuff. We're going to pick some regular points here. So x value of -1, -2, -1, 0, 1, 2. So in f of x, that's going to be 4, 2, 0, 2, 4. For g of x is going to be -2, -1, 0, 1, 2. And then for this one here, h of x, we have, well, x squared plus x, so we can just add these two values, 4 plus -2, so 4 plus -2 is going to give me 2, and then 2 plus -1 is going to give me is going to give me 0. Then 0 plus 0 is going to give me 0. 1 plus 1 is 2. 4 plus 2 is 6. Oh, sorry. This is not 2. It's 1. I am being very stupid right now. I apologize. No one caught that. So here we are. Sorry, that's my fault. 41014, because it's in x squared. Sorry, 41014, and combining that should be 20026. Okay. So now we can graph each of these functions on the graph below, and then we'll kind of analyze what we've said earlier, right? So graphing the original function f of x, which is x squared, we're going to get a function that looks like this. So that's f of x. So there's f of x. Then let's do g of x. G of x is a straight line of y equals x. So that's pretty straightforward, like such. Oh, that should have been angled a little more downwards, but it's okay. That's g of x. Okay. And now we have to draw h of x. So h of x is -2, 2 is our first point. Then we have -1, 0. Then we have 0, 0, 1, 2, and then 2, 6. So you'll see it's looking like this, and looking at the function h of x, where h of x is equal to x squared plus x, right? We can definitely assume that, well, we know that the vertex of this parabola would be -0.5. So when we plug in -0.5 into the function, we get -1.5. So we have here, let's see here, sorry, not 1.5. It will be negative 0.75 or 0.25. So that's going to give me a point here, and I can accurately graph that, or as accurate as possible, to something that looks like this. And so that would be h of x. So let's take a look at our function here. Okay, we have f of x, g of x, and h of x. So a lot of you are probably thinking, okay, what's the point of even learning this? What's the point? Like, what is this supposed to do for us, right? So let's take a look at those domains. Let's see if we can analyze something here. So I'm going to keep that on the screen as best as possible, but let's talk about the domains. The domain of the function f, right, is x is any real number, right? That is true. Okay, so x is any real number. The domain of g is also x is any real number. And you'll notice the domain of h is the overlap, right, or is the intersection of the domain of f and the domain of g. Is that still true? Yes, these are overlapping perfectly, and we see when we graph the function, the domain is also exactly the same. It's a parabola, and the domain is x is any real number. So that's true. Now, for the second part here, let's look at the range of f. The range of f is y is any real number such that y is greater than or equal to 0. The range of g is y is any real number. Okay? So we have that. The domain, or sorry, the range of h, however, is different. That y of is any real number such that y is greater than or equal to negative 0.25. Okay. Now, how did we found this by, of course, plugging in it and solving it, but this is true, and this is still a combination of actually both ranges. The only weird part is that this restriction here, right, the lowest point of our graph has been shifted according to the sum of these two functions. You'll see that when the function f of x and the function g of x intersect at 0, 0, that point's not going to change. That point still existed for h of x. However, you'll notice here, where f of x is 0 at negative 0.5 here, or that increase there, g of x starts to become lower. Adding those two y values gives you a negative 0.25. And then y is greater than or equal to that, as it's a parabola going upwards, right? Now, of course, you can find this in other ways, because if h of x is equal to x squared plus x, you can use your basic factoring knowledge to understand that this can be factored like this, and you can find the x-intercepts that way, and understand that the vertex happens in between. So there are a lot of different ways you can determine what the range of your function is, right? If you know it's a certain type of function, which you do, you've went over like 5, 6 different types of functions now, you can determine what the range would be. And it just gets more complicated when we start combining different functions, like trig functions with logarithmic functions and stuff like that. But those are few in between. But they are situations that happen, but the rules still apply. The rules don't change, right? The domains will always overlap and only exist where it overlaps. And then second, right? The range you can figure out using the function itself, right? What is the resulting function h, and find the range of that, right? Nothing has really changed from what you're doing. The only special thing you're doing is adding the function. So let's take a look at a word problem, and then that'll be it for today. This is our final example, and we'll call it a day. The student council is selling t-shirts to raise money for new volleyball equipment. There's a fixed cost of $200 for producing the t-shirts, plus a variable cost of $5 per t-shirt made. Council has decided to sell the t-shirts for $8 each. So let's write a equation to represent C as total cost and R as revenue. Okay, pretty simple. So C as total cost. So let's make it as a C as a function of n is equal to, and so the total cost is going to be the $200 plus $5 per t-shirt made. So it'll be 5n plus 200. The revenue, R of n, is going to be just 8n. So the sum of both, right? So that's pretty straightforward. The profit is the difference. We know that profit should be the difference between revenue and expenses. You make a profit if your revenue is greater than your expenses, your cost, right? If you sell more and make more money from selling, and then you pay off whatever it required for you to buy your product or prepare it, then you have profit, right? That's the amount of money you make at the end of the day. And so for us, we can say P of n, P of n is equal to the difference between revenue and expenses. So P of n is equal to R of n, your revenue, the money you're making, minus C of n, the cost of your business. And so P of n is equal to 8n minus 5n plus 200, right? I'm going to put them in brackets, just like when we substitute values. You put them in brackets because the signs are going to change things. So P of n is equal to 8 of n minus 5 of n minus 200. So the final function, P of n, the profit, is going to be 3n minus 200. Okay, so there we have it. So now part C asks us, under what circumstances will student council lose money, or when will it make money? So pretty simple. Profit of 0 means that they make or lose no money, which means making money is P of n is greater than 0. So what we can do is we can say that if P of n is equal to 3n minus 200, then 0 greater than 3n minus 200 must be profit, making money. So we're going to try to solve for this here. So we're going to try to figure out what value of n will make this greater than 0. Right? So that's what we want. Actually, let's solve for break even. Actually, this might be easier to understand. Sorry. Let's go break even. So let's say we make no money gain, no money loss. We want to find where exactly is like our break even point. So we're solving for n. What makes n 0 here? We're going to get 200 is equal to 3n. And then 200 divided by 3 equals n. So your break even point is 66.67, and we can't really have 66.67 t-shirts, so selling more than 67 t-shirts will make money, while selling less than 67 will lose money. And that's it. So we're going to find the break-even point. We're going to figure out what N is, how many t-shirts are required to make break even, which means selling more than that many t-shirts will generate money, and selling less than that, though that amount of t-shirts will cause us to lose money, right? And our final question here, identify the domain and range of the cost, revenue, and profit functions in the context of these problems. So domain, range, so on and so forth. When we talk about application problems, you want to talk about practical domain and practical range. Like, what is the domain that actually exists? Like, you can't have a domain. When we're talking about t-shirts, negative t-shirts don't exist. So you can't go into the negative numbers, although yes, the function is possible to go in there. That's the practical answer, is that we can't have negative t-shirts. So can that function go less than 0? No, not exactly, right? So let's take a look here. The domain of P, or sorry, let's go for the domain of C, right? So the domain of C is equal to N is all integer numbers this time. We can't say real numbers because we can't have decimal t-shirts, right? So N is the set of integer numbers such that N is greater than or equal to 0. So we can't have less than 0, but we can have no t-shirts. That is something that exists. And N can only be possible in the integer numbers. We can't have 1.1 t-shirts. We can't have 1.3 t-shirts, right? We can only have whole number t-shirts. So that would be the integer numbers. Which means the domain of R, the revenue, is the same idea, right? Where it's limited on the t-shirt, so it's the set of integer numbers, and N has to be greater than or equal to 0. Following the rule, when we add or subtract functions, the function that exists is where the domain intersects, right? Are these domains intersecting? Yes. The domain is exactly the same for both, which means we can quickly assume that the domain is exactly the same for the profit function, which we subtracted the cost and revenue from. So that's domain. Let's find the range of C. So the range of C is such that, well, we'll do capital C because that's our cost. C is, in our case, also going to be an integer value, and therefore such that C is greater than or equal to 200. Okay. So in our original function, since 0 is the lowest value that can go, it's going to start at $200 for the cost, and it's going to go up from there. The range of the revenue is going to be R is the set of integers where the revenue is going to start at 0, because we have revenue is equal to 8n, and n, the lowest value n can be 0, so 8 times 0 is 0. So it's going to be greater than or equal to 0. And the revenue of the profit, we subtracted. So once again, the lowest x value that both of these functions can start at is 0. The y value for both of these functions is going to be 200 and 0 respectively. And the function of P is R, the revenue, minus C, the cost. So subtracting the Y values, 0 minus 200 is going to give me the lowest value our profit can be, which is negative 200. And this, you don't even have to think of it the way I just thought of it either. This is something you can figure out just from like a table of values, right? You plug in 0, you can quickly solve it. Like if you plug in 0 to this function, what's the lowest value the profit function can be? It's negative 200, right? Any n value greater than 0 is going to increase that value. So these examples, these word problems, they're not difficult. The concept is actually pretty straightforward. Can you add and subtract algebra? Can you do algebra? Yes or no? Right? If you can do algebra, you can do this. That's what I believe, at least for this lesson, is. It's actually a lot simpler than some people are envisioning it. So just keep in mind, if you can add functions, you can figure out the domain, figure out where the domain overlaps, and then the range is like table of values still. You're still going to solve for your y values, right? You need to know what the y values are, and then you can plot and graph whatever the function is. Okay? And that's it. You have your homework listed down below at the bottom there. So if you have any questions, please feel free to comment or email me, and I'll be happy to answer your questions. And tomorrow, so actually I need a vote from the class now. I have two thoughts. So for those currently watching the live stream now, if you can kind of message in chat, there's two options that we can do for tomorrow. Number one, we can just do a regular lesson. We can move on to 8.2, which is multiplying and dividing functions. So we can do that. Or we can leave that for Thursday and have office hours tomorrow. So if we do a lesson tomorrow, office hours would be on Thursday. If we don't do lesson tomorrow and office hours tomorrow, then you're gonna have your lesson on Thursday. I personally think having your office hours on Thursday is better this week, only because you'll have two lessons and then you'll have your office hours, so you can kind of figure out what questions you want to do. Office hours are where I'm just going to be here live streaming for around 20-30 minutes. Whoever shows up can show up, ask any questions, and I'll be going over specific questions you ask in class, like here on this screen. I'm not going to be like teaching an actual lesson during office hours. It's just going to be answering questions that students may have, and then if no one comes, then I'll just end it early, and it doesn't really matter. Are you gonna return the textbooks? I'm trying to figure out the details of that. I'll let you know if I get any information on those textbook returning policies. I gotta double check. We would highly want those textbooks back, yes. And you can actually start visiting the school for your locker and stuff tomorrow. I'm going to be posting an announcement right after this class ends about the instructions on going to school to pick up your leftover stuff or something like that. So please keep your eyes out on Google Classroom. If there's no other comments on when office hours will be, we're going to do a lesson tomorrow, and then we're going to do office hours on Thursday. Okay? All right. So that's it for today. Have yourselves a good one. Try out some of the problems from today, and I'll see you tomorrow for 8.2. Peace out.